Hi, in this tutorial, I'm going to introduce this KSTET exploit. The KSTET exploit actually will perform the DLL side loading. What happens is our vulnerable chat server has a buffer overflow vulnerability. On our cat VM, we are going to inject our malicious string, which includes our malicious shellcode, into the vulnerable chat server. When the shellcode works on the Windows VM, it will actually load a malicious dynamic library from the attacker's compute. What will happen when the malicious dynamic library is loaded? As we know, when we actually load a dynamic library into a process, the main function called the DLL main of the dynamic library will run. So in this case, the DLL main contains a reverse TCP shell, and it will call back to the attacker's computer and open a shell on the attacker's computer. Okay, so that's the whole story. So I'm not going to explain all the details here. Okay, and I'm going to show you the final attack. So let's look at our code here. So here is our shell code, right? This is our shell code, but let me first explain our attack code. So this is our attack code. And so you can see here, we're going to import socket module, struct module, sys module. So this Python program accepts one command line parameter, which is the IP address. You can see here, the port number is 9999, which is the port number of the vulnerable chat server. That you can see here, this is our shell, right, code. And then here is our malicious string. So we are trying to attack the KSTET command. Then you can see here, then we have some 90 as padding. Then we have the shell code, and we have another padding here. And we have an address. This is the address to a jump ESP instruction. Okay, and so this address will overwrite the return address of the victim function. Now, when the victim function returns, right, jump ESP will run. When jump ESP runs, it jumps to here. This is another jump instruction. It will jump back to the start of our buffer and will run the shellcode. Okay, so you may ask, why do we need this jump short, right? Maybe we may put the shellcode here, right? So the issue is, so we don't have enough space here because of how the program is structured. I mean, the victim program is structured, and so that we have enough space before this jump ESP address. So that's why we need to jump back to the start of the buffer. Okay, and that's where our shellcode is located. Okay, so let me show you how we actually, perform the attack. So first thing, we need to start this this SMB server. So the victim chat server runs on Windows. So we needed to use the SMB protocol to load the remote dynamic library. So where is our remote dynamic library? is here. Okay, and so let's run this one again. Good. Of course, because the malicious dynamic library will perform, you know, the reverse TCP shell collection, right? So that's why we need to start this NC command and listen for the incoming collection. Okay, and also here, let's go to Windows. So I need to start my WeChat server. Okay, so now the vulnerable chat server runs. And here, okay, and so I come back. So this is our exploit code, right? So this is a Windows VM's IP address. So we just actually hit, you can see it works, okay? And when the dynamic library is loaded into Windows, okay, the DLL main runs, which starts collecting back to the Kali computer. So dir, okay, so this is the demo.